Hi everyone, this is Purti. Today we are going to discuss about the two error detection method, that is the checksum and the CRC. Let us start the session with what is a checksum. As you can understand, the name itself says that checksum means it is going to check the sum. So the sender is going to create the message and with the message it is going to calculate the checksum and it is going to attach that checksum to the message. We will be learning about how the checksum is going to be created and how it is going to be validated. So obviously in the sender side the checksum is created and in the receiver side the checksum is validated. So after validation, if the receiver finds out that there are no errors, then the packet is accepted or the data is accepted. Otherwise, the data is rejected. Now let's see how this checksum is created in the sender side. The operation of creating the checksum in the sender side involves four steps. Step number 1. Break the original message into a number of blocks with n bits in each blocks. For example, if we have 20 bits and we want 4 blocks, so we will have 20 bits in 4 blocks where 5 bits in each blocks. And step number 2 is we are going to sum all the k data blocks. We know in the previous step we have broken the original message into k number of blocks and we are going to add or sum all the k number of blocks. The summation sometimes may generate a carry and add the carry to the sum if any such carry is generated. And the last step is just do one's complement to the sum. Whatever we get after performing the one's complement, that is called as the checksum. So the checksum will also be of n bits. Every block of data is of n bits and the checksum will also be of n bits. So basically the operation at the sender side involves 4 steps and we have seen all the 4 steps in points. Let's consider the data unit to be transmitted is this one. Now we have the step number 1 is breaking the message into blocks. So we are breaking this original message into 4 blocks. As you can see, each block has 8 bits. We know the sender has created these 4 blocks. The sender places all the 4 blocks in order to perform the addition. So the sender is now performing the binary addition. Now we will be performing the binary addition here. You can see here 0 plus 1 is 1. 0 plus 1 plus 0 is 1 again. 1 plus 1 plus 0 is 1 0. So 1 is taken as the carry here and 0 is written here. 1 plus 0 plus 0 plus 1 is 1 0 again. So 0 is written here and 1 is taken as the carry again. 1 plus zeros plus 1 is 1 0 again. So it's the same. 1 is taken as the carry and 0 is written here. Now 1 plus 0 plus 1 plus 1 plus 0 is 1 1. So 1 is written here and one more 1 is taken as the carry here. So again it is the same. 1 plus 0 plus 1 is 1 0. So 1 is taken as the carry here and 0 is written here. Now 1 plus 1 plus 0 plus 1 plus 1 is 1 0 0. So 0 is written here and these two are the actual carry. Now this carry will be added over here again. After bringing down the carry over here, we will be performing the binary addition. Again, 1 plus 0 is 1 here. And then 1 plus 1 is 1 0. So 1 will be taken as the carry over here and 0 here. So this 1 carry is written down here and the rest of the numbers will be written as it is. In this next step, we will be performing the ones complement. What the ones complement means is converting all the ones to zeros and zeros to 1. So here the 1 is converted to 0 and 0 is converted to 1, 1 is converted to 0 and so on. So this is the final checksum. The result which we have got by doing the ones complement is considered as the checksum. Now this checksum will be appended to the receiver side. What receiver does? It collects all the data blocks including the checksum and the receiver sums all the data blocks and the checksum and if the result is all ones it accepts, otherwise it rejects. Let's see with the same example. As you can see that this block of data is from the previous one and it is as it is. And the last block of data is the checksum and it is being sent from the sender side to the receiver side. Now we will be performing the binary addition to the same as done previously. 0 plus 1 plus 0 is 1. 0 plus 1 plus 1 is 1 0. So 0 is written here and 1 is taken as the carry. So 1 plus 1 plus 1 plus 0 is 1 1. So 1 is written here and 1 is taken as the carry. So 1 plus 1 plus 1 is 1 1 again. So 1 is written here and 1 is taken as the carry. So again it is 3 ones. So again it is 1 1. So 1 is written here and 1 is taken as the carry. And again it's the same. So 3 ones plus 0, it is 1 1 again. 1 is written here and 1 is taken as the carry. So again 1 plus 0 plus 1 plus 0 plus 1 is 1 1. So 1 is written here and 1 is taken as the carry. So now it is 1 plus 1 plus 0 plus 1 plus 1 is 1 0 1. So 1 is written here and 1 0 is the actual carry. So 1 0 is got down here and we will be performing the addition again. After getting down the carry here, we will be performing the addition again. So 1 plus 0 is 1, 0 plus 1 is 1, and all this rest of the values are got down as it is. Now as you can see, the result is all ones, so the receiver will accept the data. The next error detection method is the CRC, that is the cyclic redundancy check. And we know that any error detection technique, we are going to append the redundant bits with the message because this redundant bit only will be enabled to the receiver to detect whether there is an error or not. So likewise, CRC is also going to generate some bits and these bits are called as redundant bits. And in this technique, these redundant bits are specifically called CRC. Let's solve a problem now. Find the CRC of the data block 100100 with the divisor 1101. The protocols that the sender and the receiver mutually agree upon will decide the divisor. So the divisor will be known to the sender and the receiver. So based on the divisor, the CRC is going to be calculated or the CRC is going to be generated in the sender side and verified in the receiver side. Now for time being, let's assume the divisor is 1101 and we are given that the data blocks that is 100100. Let's look at the generation of CRC at the sender side. The CRC generation at the sender side involves 4 steps basically. Step number 1. Find the length of the divisor and we are naming it as L. And after finding the length of the divisor, in step number 2, we are going to append L minus 1 bits to the original message. Suppose if the length of the divisor is 5, then we are going to append 4 bits to the original message. Don't get confused. This appending 4 bits to the original message is not the CRC. For doing the operation, we are going to append L minus 1 bits to the original message and then perform binary division operation. So we have a divisor and we have a message that is appending L minus 1 bits. Now let's start performing the binary division. After performing the binary division, we will get two results. One is the quotient, another one is the remainder. Then whatever we get as the remainder, that's the CRC. In the question, message is given and the divisor is given. Here we have 4 bits in the divisor. So L is equal to 4 here. So L is equal to 4 means we are going to append L minus 1, that is 3 zeros are appended to the message. After appending the zeros, let's start the binary division. So here 1001 is the divisor. So 1001 1 times is 1001. So we will be performing XOR operation here. So if 1 and 1, if the values are same, then the answer is 0. And if the values are different, the answer is 1. So here 1 1, for 1 1 it is 0. 0 0 it is 0, 1 0 it is 1 and 1 1 is again 0. So now we will be getting down 0 here. After getting the 0 down here, again 1101 time is 1101. So 10 is 1, 0 0 is 0, 0 1 is 1, and 1 1 is 0. We will be ignoring this part. We will be considering only 3 bits here. So next again we will be getting down the 0 here. Here 0 1 is 1 because they're different values. 1 0 is again 1 because it is different values, and 0 1 is 1. So 1 1 is 0. So again we will be getting down 1 0 here below. So in the next step we will be taking one time of 1101. So here in the question part, we will be writing it as 1. So 1 time of 1101 is 1101. After performing the XOR operation, we will be receiving 0011 as the reminder. But here, we will not be considering 00. So only 1 1 is considered. There are only 2 bits. So with 2 bits, we cannot perform the operation. So we will be getting down both the values next. So we will be writing 0 in the question part. So after getting down both the zeros, and again we will be performing the XOR operation. So the final value reminder is 001. So this is the CRC. So the data transmitted will be 100100001. So now after the message is being sent to the receiver side, the divisor will remain the same, but the dividend will be 100100001. So we will be performing the same steps as performed in the sender side. So you can go through the steps here as it is. So here in the final part, the remainder will be all zeros. You can see here in the remainder part, 000, the 3 bits of zeros. So this means that data has been accepted by the receiver. Thank you.